Hello everyone. My name is Sheena, and in this video, I'm going to walk you through how we convert a list of DNA like string into radix 5 number and apply a hash function to those values. And 1 minute. Yeah. And finally, insert them into a hash table while using chaining to handle any collisions. So let's begin with a quick overview of our data set and what we are going to do. So this is the data set we are going to use. These are the string made up of alphabets. And this is how we map each string to the number like a equals to 0, c equals to 1, g equals to 2, t equals to 3, and n equals to 4. We will follow these steps like convert each string into a decimal number using radix 5 notation and pass the resulting number through a hash function and insert the string into a hash table using chaining. If multiple string hash to the same index, we will use the hash function, which is h of k equals to k mod 7. And the hash table has 9 slots, meaning we can use the index position from 0 to 8. So let's start with the step 1, which is convert string to radix 5 values. So in this step 1, um, now let's talk about radix conversion. Each of our strings has 5 characters. Since the alphabet has 5 letters, we use base 5 or radix 5. The leftmost character has the highest weight, which is 5 to the power of 4. And the rightmost character has the smallest and 5 to the power of 0. The formula looks like this one. Like S0 into 5 raised to the power 4 plus S1 into 5 raised to the power 3 plus S2 into 5 raised to the power 2. Likewise, we will go till 5 raised to the power 0. So let's apply this formula one by one for each string. So the very first string is ACGTT. And here is the mapping for all the alphabet here. So if we use this formula on this string, then we have to multiply plus we have to do the addition of each string. Sorry, of each alphabet. So the final result will be 193. And now we plug this into the weights and we got the result 193. Similarly, we will do this for GTAAT. These are the values that we have used, like its mapping, and we are going to use the same formula, and the final result will be 1628. Similarly, we have to do for ANAA, triple C, for 5 times C. Here the value for the C equals to 1. Then we have to, multiply every character with the 1, and then we have to do the addition. So the final result will be 781. Same for the TTN, and the final result will be 1969. So here um, we have taken the summary for each string. So this is a summary table. Here it will give the string and the radix 5 value by using the above formula, this formula. Let's go to the second step, which is hashing the decimal value. So here in the hashing the decimal value, we will use the same summary table. So um, here the formula is h of k equals to k modulo 7. Let's apply it to each of the decimal values. So the first string is ACGTT. Here we are the final value that we have calculated with the formula of radix 5 is 193 for the ACGTT. So we have to perform a modulo function. So if you perform the modulo function, we can write it as like 193 modulo 7. So the result will be 4. Similarly, we have to perform the modulo 7 with 1628, which 1628 is the value of GTAAT. So, so let's record all these results by using modulo 7 formula. And this is the value, final value that I got. So we can already see that the index 4 has multiple string hashing to it, and this will require chaining in the next step. So let's move to the next step, which is step 3, which is inserting into hash table using chaining. So we are now ready to insert this string into the hash table of size 9. So here's how the insertions go based on the hash index. So index 2 will be is TATTN, and index 3 is ANAAA, and index 4 is ACGTT, GTAAT, and 5 times C. All collides and changed. Here, the final layout of the hash table is this one. So on 0 we don't have anything, on 1 we don't have anything, but we have TATTN on index 2, ANAAA on index 3, and on 4 we have 3 strings. So what's happening at index 4 is called collision resolution using chaining. So all three strings are stored as a linked list or dynamic array under the index. Chaining allows to avoid data loss where 2 or more items hash to the same location. Coming to step 4, which is efficiency consideration. Let's quickly analyze the performance of each step. Like radix conversion is linear in the size of the string, but since each string has only 5 characters, this is big O1 in the practice. Hash computation using modulo is also a constant time, which is big O1. And insertion with chaining is the best case where there are no collision, and the insertion is big O1. In the worst case scenario, all elements hash to the same index and we have to traverse a list that is big O(n). On average, so on, like I can say overall, our approach is efficient and scalable. Sorry, I missed average. So on average, with a good hash function and enough bucket, insertion remains close to big O(n). So in summary, I can say that we started with a set of strings and map each one to a number using radix 5 conversion based on a custom alphabet. Then we used a hash function to determine where each value should go in the hash table. When we multiple strings hash to the same index, we use chaining to store them without losing the data. So the process mimics how a real world programming language implement hashing, uh, um, maps, like how they implement the hash maps, such as Python dictionaries or C++ understood maps. And we have such a structure is like we have a structure is foundational to many real world data structure. So yeah, this is my video for on these 3 concepts. Thank you.